Welcome back to All This Math. This is Professor Parker with you at your service. And please, if you haven't already, please subscribe to the All This Math YouTube channel. Please subscribe and also hit the notification button so whenever there's new content, you'll be made aware of it. All right, let's jump into today's lesson. So today we're going to be talking about the segment addition postulate. The segment addition postulate. I know that might sound confusing, it might sound intimidating, but trust me, I'm going to break it down and I'm going to make it very simple for you, right? So what is a segment? A segment is a piece of, basically it's a piece of a line, right? Lines go on forever in both directions. They never stop. They go on to infinity, but a segment is just a piece of a line, right? A segment could be 5 inches, 2 inches, 1 centimeter, 2 centimeters, or what I have drawn up on this board. T to V is a segment, right? Addition is when we add things together, right? We find a sum. And a postulate, that's just a word for a rule, right? A rule, a law, a theory. Those do have some differences, but for the purposes of what we're doing today, the minor differences between rules, laws, theories, and postulates are not really relevant, right? So let's read the problem. It says TV equals 14x minus 8. Don't worry. That might sound confusing. I'm going to break it down for you. And we need to find TU. First of all, what is TV? What does that even mean? TV means this. TV is a segment. TV is the segment or the length between the point that's labeled T and the point that's labeled V. So from here to here, basically. From here to here. That might be the distance from your school to your house, right? That's a segment. That's a certain length of space. So TV represents the length from here past you all the way to V, all right? And we don't know exactly how long that is. We don't know a single number that we use to represent that. We have what's called an algebraic expression. This is an expression, 14 times x minus 8. So 14 times some number that we don't know minus 8 is equal to the length from here all the way to here. Now, what are we trying to figure out? We always got to know what our end goal is. What's our end game, right? Our end game is to figure out the length of TU. TU is the length from point T to point U, from point T to point U. Now, we're going to use the segment addition postulate to do that, right? Because what we do is oftentimes in geometry, really just about all throughout geometry, is we take a theory or a postulate or a law, and we use that to create an equation. And then once we create the equation, we're not even really doing geometry no more. Now we're doing algebra. So we just have to know how to solve equations. But first we got to set up the equation. But we use the theory that we're given in order to tell us how to set up the equation. So I know through the segment addition postulate that the length of this segment, TU, plus the length of this segment, UV, is equal to the length of the whole thing. So this piece, because it's next to this piece, these two pieces put together or added together are equal to the whole thing. So I'm going to write that down because that's important because we need to be able to visualize what we're doing. So basically, what I'm trying to say is this. TU plus UV is equal to TV. Now let that marinate for a moment, right? TU is from here to here. UV is from here to here. TV is the whole thing. So all we're saying is like imagine you made a hoagie, right? You made a hoagie, you cut it into two pieces. The length of one piece of the hoagie plus the length of the other piece of the hoagie is going to be equal to the length of the whole hoagie. So if you bought like a 12-inch hoagie, you cut it into an 8-inch piece, and you cut another smaller piece for like, a young boy or something, which is like 4 inches long. That's 8 inches plus 4 inches. It adds up to 12 inches, the original 12 inches that it was in the first place. That's all we're doing here. If you can understand that concept, then you can understand the segment addition postulate, which is this. Now, once you understand the concept, now we got to talk about how to set up the equation. We set up the equation, and once we set up the equation correctly, then we use algebra to solve the equation, but we have to know the steps of how to solve the equation. So what I want to know is what expression is equal to TU? So we look up here on the diagram. I see this, and I wrote it in blue on purpose because I wanted to distinguish it, right? TU is equal to 9x plus 2. So just like TV is equal to an expression, TU is equal to an expression. So TU is 9x plus 2. So I'm going to replace TU with a 9x plus 2. Check me out. Boom. So TU is gone. Now it's 9x plus 2. Then I write my plus sign. I bring my plus sign down again. UV is a number. UV is just a plain old number, the number 5. So that's 5 units long. So I write 5. Then I write my equal sign. And then TV, I also know what TV is. I know what expression is equal to. It's equal to 14x minus 8. So now I got equals 14x minus 8. So now this is my equation. So now once you write the equation, the geometry is over. The geometry is over. Now we're just doing algebra 1. That's all we're doing right now. We're doing algebra 1. Now, there are many different ways that you can start this equation. One thing that I would do is I always like, this is just my twist. I like to combine like terms first, right? Like terms meaning all constants are alike or plain numbers are alike. All variables with the same exponent are alike, but they have to be on the same side of the equation. So 9x and 14x are like terms, but you can't combine those because they're not on the same side. 9x is on the left side, 14x is on the right side. We could do something to put them together, but we can't technically combine them, right? But I'm going to do this 2 and this 5. The 2 and the 5, they're going to add together. This is going to become 9x plus 7, which equals 14x minus 8. Now, my goal is to isolate one single x by itself on one side of the equal sign. Now, I like to have my x's on the left side of the equal sign. So what I'm going to do is I'm going to get rid of this 14x right here. I'm going to get rid of it by doing the opposite operation. So think of this as a positive 14x because there's no minus sign in front of it, right? This minus sign goes with the 8, right? This minus sign don't really have nothing to do with the 14x. This is a positive 14x. The opposite of positive 14x is negative 14x. So that means you would subtract 14x to get rid of it. Now, again, why do I want to get rid of it? I want to get rid of it because I got too many x's. I want one x by itself on one side. Right now, I got 2 x's. I got 1 x too many. So whenever you're doing math, you should always be thinking about why am I doing that? Don't just try to memorize steps. Think about why am I doing that? Why does this make sense? Why do I need to do this? Why do I need to get rid of 14x? Because I'm trying to have one single x in one place on one side of the equal sign. That's why. But if I subtract 14x on the right side, I got to also subtract 14x on the left side. Boom. So 9x minus 14x is negative 5x. We got to know how to add and subtract positives and negatives. We got to know how to do that. That's mandatory. Then we come down here, bring the plus 7 down, bring the equal sign down. This is gone. And then bring this negative 8 down. Now, like I said, I want to get x by itself. So I got to get rid of this 7, and then I'm going to get rid of this negative 5. But I'm going to get rid of the 7 first. So this is a positive 7. So I need to do the opposite of adding 7 to get rid of the 7, right? So the opposite of adding 7 is subtracting 7. So I'm going to do minus 7. Minus 7 right here. Also minus 7 over here. Boom, that's gone. This don't change yet. Bring the negative 5x down. Negative 8 minus 7, negative 15. Again, we have to know how to add and subtract positive and negative numbers. Think about that negative, that number line. Think about the number line. You start at negative 8. Whenever you subtract, you move to the left. So we're going to move 7 spaces to the left. We would end up at negative 15. All right? Now, I want to get rid of this negative 5. This negative 5 has got to go so that I can solve for x, right? So I have to do the opposite operation. The opposite of multiplication, because this is negative 5 times x. Don't think of this as a multiplication sign. It's not. It's a variable. It's a variable. But because there's no symbol in between the negative 5 and the x, that means that we are multiplying. So we do the opposite of multiplication, which is division. So I divide by negative 5 on the left. I divide by negative 5 on the right, because we got to be fair. But if we do on one side, we got to do on the other side too, right? That's going to give me x. And this is going to give me positive 3, not negative 3, positive 3. 2 negatives. In math, 2 wrongs make a right. Negative divided by negative gives me a positive. So x is positive 3. Pro tip right here. A lot of people will get x equals 3 and think they're done and just write that down, right? That is not the answer. You are not asked what x is. You need to find what x is in order to actually answer the question. You're told to find TU, not just solve for x. You're told to find TU. Now, I can use x to find TU, right? TU is 9x plus 2. So check this out. This is what you do. TU is equal to 9x plus 2, right? So since I know that x is 3, that means that TU is really 9 times 3 plus 2. 9 times 3 plus 2, because x is 3. I did all this work to figure out that x was 3, so that way I can then figure out what TU is. So I just do 9 times 3 plus 2. 9 times 3 is 27. Don't make the careless mistake and do 9 plus 3 and get the wrong answer after you did all this work, right? 9 times 3 is 27. 27 plus 2 is 29. Now, I want to check my work, right? I don't want to just stop here and say, oh, all right, TU is 29. I think it's 29, but I want to check my work. So this is how I'm going to check my work. I'm going to check my work by going back to this, right? So what I'm saying is TU plus UV must equal TV. So TU was 9x plus 2. So I think TU was 29. So I replaced TU with a 29. Right, the plus sign. What was UV? UV was 5. What was TV? TV is 14x minus 8. 14x minus 8. So check this out. This is what we do. We do 14 times x, which is 3, minus 8. Now, what's 29 plus 5? That's basic math. 29 plus 5 is 34. What's 14? Over here on the right side, you got to know order of operations. That's another thing. You got to know order of operations. Don't do 3 minus 8 first. That's wrong. You have to multiply first and then subtract. 14 times 3 is 42. 42 minus 8. Now the question is this a true statement? Right? See, if you sit there and like listen to somebody tell you something and you can assess in your mind mentally whether they lying or not, then you can also do algebra. Because that's all we're doing right now. I told you that TU equals 29. I told you that x equals 3. Now you go through these steps to find out whether I'm telling the truth or not. Now I could be, I could have made a mistake. I could be well intended and I could have just made a mistake, or I could just be flat out lying to you. But either way, you can do this work and check your answer in order to tell if this is true and if this was true. So now we got to know, okay, is 34 equal to 42 minus 8? And yes, 34 is equal to 34. Well, 34 is equal to 42 minus 8 because 42 minus 8 is 34. All right. So as long as the left side equals the right side, something's adding up. So just like when you're sitting there and you're listening to somebody talk and they telling you a story and you know they're lying and you sit there in your head, and you be like, yo, something ain't adding up because they lying. Something ain't adding up because they lying. Here, this adds up because 34 is equal to 34, right? They're the same number. So that's how you check your work. And I'm a strong advocate of people checking their work. A lot of people like to run through problems. As soon as they get to the answer, they done. Let me go into the next problem. But I'm a strong advocate, like I said, of checking your work because that empowers you. Because once you know how to check your work, you don't got to wait for nobody to validate you and tell you if your answer's right or not. You tell yourself if your answer's right because you know how to check your work. You go back to the original equation and then you just replace all the numbers and the values and you check to see if the left side is equal to the right side. All right. Now, I hope that was helpful. That's a little bit on the segment addition postulate. I'm going to do some more videos on the segment addition postulate in the future. But in the meantime, yeah, I hope that was helpful. And please, again, if you have not subscribed to the channel, please subscribe to the channel. Go ahead, hit that button on your phone or on your laptop, whatever. And also turn on the notifications. Turn on the notifications so that when I put up new content, and I'm putting up new content on a regular basis, you'll be notified. And also share these videos. Tell some people about it. Share these videos. Share these videos with adult learners. Share these videos with people with children. Share these videos with everybody. I want everybody to be able to benefit from what we're doing at All This Math. And as always, do remember that there's all this math all around you. Peace.